Physics Part 426. The rate at which the amplitude of the carrier wave varies is related directly to the frequency of the information signal. Note the amplitude modulation is not the same as the superposition. Superposition involves the addition of displacement, whereas the amplitude modulation is achieved through the multiplication of displacements. In frequency modulation, the amplitude of the carrier waves remains constant. The frequency of the carrier wave is made to vary in synchrony with the displacement of the information signal. The change in the frequency of the carrier wave is a measure of the displacement of the information signal. The rate at which the carrier wave frequency varies is a measure of the frequency of the information signal. The use of a carrier wave allows different radio stations in the same area to transmit at the same time. Each radio station has a different carrier wave frequency. The receiver is adjusted or turned to the frequency of whichever transmitter is desired. The receiver accepts the signal transmitted on that particular carrier wave and rejects other carrier wave frequencies. We've got example for you. A sinusoidal carrier wave has a frequency of 800 kilohertz, an amplitude of 5 volt. The frequency deviation of the carrier wave is 30 kilohertz. That is for every 1.0 V change in displacement of the signal. The frequency of the carrier wave changes by 30 kilohertz. The carrier wave is frequency modulated by sinusoidal signal of the frequency and frequency 10 kilohertz and amplitude 2.0 voltage. Describe the modulated carrier wave. Now it's your turn. The carrier wave has a constant amplitude of 5.0 volt. Its frequency changes from 740 kilohertz to 860 kilohertz and back to 740 kilohertz. This change of frequency occurs 10,000 times per second. Amazing, 10,000 per times per second. Now it's your time. Now it's your turn. A sinusoidal carrier wave has a frequency of 750 kilohertz, an amplitude modulated by sinusoidal signal of frequency 3 kilohertz and amplitude 0.5 volt to describe the modulated carrier wave. Example number 2, the variation of time of the displacement of an amplitude modulated radio wave is shown in the figure. For this wave, determine the frequency of the carrier wave. For this wave, determine the frequency of the information signal. The figure shows a carrier wave frequency that has been amplitude and modulated by the signal having only one frequency. If this wavelength is analyzed, it is found made up of 3 frequencies. The central frequency is Fc, frequency of the carrier wave. It has the largest amplitude. The other 2 frequencies, Fc and Fs, and Fc minus Fs, are known as slight bands and sideband frequencies. Slight band frequency and sideband frequency. Well, the frequency is the frequency of the information signal. The bandwidth is the range of frequencies occupied by the amplitude of modulated waveform. This bandwidth is equal to 2fs for